Hello and welcome to this video about Python integers for data handling. We are excited to have you here, and in this video you will learn to use Python integers, which are a fundamental tool to be able to use Python for data handling, and also a fundamental tool for any type of computations with computers. Python integers are a necessary tool for all types of basic counting and data handling. We can use Python integers to represent counts of items, represent the number of iterations of a function, memorize any type of number, represent the location of an object in a list or an array, or, for example, an integer can be used as a representation of change in a function. Let's talk some more about Python integers. Integers are a fundamental data type in Python, and a Python integer is defined as a native Python object. When we say that the Python integer is a native Python object, we implicitly compare it against the machine code integer, which conceptually most often is an address to a position in your random access memory that holds a value, most often nowadays of the 64-bit data type. The Python integer is different from this in that it provides object methods and encapsulation, a piece of code protecting the integer number data value from being accidentally overwritten. Python integers are therefore useful and accessible from a data handling viewpoint. And as we in this video aims at data handling rather than object orientation, we will not study the details of object orientation with Python integers, but study how Python integers are useful for data handling purposes. Noteworthy properties of Python integers are that when we talk about Python integers, we usually abbreviate them as single ints or many ints. If everyone knows that we use Python, we may drop the word Python. A Python integer can only consist of whole numbers without decimals. And this is important. Integers in Python 3 have unlimited size, which makes Python integers very easy to use and very convenient to use for data handling purposes, as there's only one type of integer, not 2, 4, or 8 types of integers. And this means that a Python integer can be any type of number, such as 34 minus 91, it can be 1, it can be millions and billions, but what it cannot be is an integer with a fraction. Different Python data science and machine learning libraries may use other types of integers than Python integers. And this is mainly due to speed, as a Python integer is much slower than an integer which directly can be fed into a machine 64-bit coded library. And it is therefore important to know your integers and libraries. And this is in particular important when you use libraries which has functions which create returns, because these libraries often accept Python native objects as input, but may return for example, a NumPy 64-bit integer instead of a Python integer. And this can convert your Python integer into a NumPy integer, which is fast but not perfectly convenient for all types of data handling. So, is speed important for data handling, and how do Python integers' slowness affect data handling? This is the case. Most persons doing data handling spends 97% of the time planning and coding, and 3% of the time waiting for computations. Python integers speed up the 97% greatly, and other integers may speed up the 3% greatly. Take your pick. I give you this idea. When you develop stuff, Python integers and dynamic typing is fast. When you have a piece of code that is reused time after time, time can be spent on making it faster. So right, now we'll talk some about how Python integers are created. So, how is a Python integer created? Python creates an integer by assigning an integer value to a variable. For example, the variable whole num in this example on your screen. And in this example, we assign the variable whole num the value of 5, and we will put a comment next to it. So in this example that you can see on your screen, we take the variable whole num, we assign it the integer value of 5 with the equality sign. So we have whole num equals 5. And then we write the comment sign, which is the hash mark, and to the right of the hash mark we type integer value to remind us that 5 is an integer value and that the variable is an integer because we assign it an integer value. And we can use the print command and print the value of the variable by printing the variable between the parentheses of the print command. And when we run this code, it will assign the variable whole num, the variable 5, and it will print 5 to the screen. And in this case, we use the print command to show that the variable exists and that it has a value. And another way to check the object type is to use the type function, for example, to print type of, for example, whole num or an int. All right, now it is time to type some integer code. So let's start our code editors and we will show you this code and how to run this code in practice. All right, having started our code editors, we will type some Python integer code. And a great exercise for these master Python for data handling videos is to replicate the code which we are typing. And this code which we are typing will be downloadable from the course resource page. But as an exercise and to learn to type Python code and to integrate it in your memory, it is important that you actually type this code in practice. And typing this code in practice means that you will learn the most from this video. Otherwise, it is easy that these videos just become like a book which you will open every time you write this code. So right, now we'll start to type some code and we will start typing a comment sign which describes our code. So we will type Python integers like this. And we will create our first integer. And we could say Python integer. And we type whole num equals 5. And this Python integer is created through assignment. And this means that this Python integer is created by the sign of equality and the number 5 when we run this code. And to show this, we will print whole num. And this print instruction will print the value of the integer whole num when we run this code. And in this case, the value is 5. So let's run this code. And to run this code in this code editor, we use the run button here, or you could use the run menu here. So let's run this code. And here you can see that it typed 5 to our screens. And now we'll create more integers and add them together using assignment. So we type create more integers and add them together to create new integers through assignment. So we type num2 equals 3. And this is an integer value. And we type num3 equals num2 plus whole num. And here we will say that an integer value plus an integer value is an integer value. So we print num3. And in this case, it will become 8. Because num2 is 3 and whole num is 5. And 3 plus 5 is 8. So let's run this code. And it printed 8 to our screens. And now we'll test subtraction, multiplication, and division. So we type test subtraction, multiplication, and division. And we begin with subtraction. So we create num4 equals whole num minus num2. And here we state that an integer value minus an integer value is an integer value. And we print num4. And in this case, it will be 2 because 5 minus 3 is 2. So let's run this code. And it printed 2 to our screens. Now we'll test multiplication. So we create num5 equals num4 multiplied by num3. And here we state an integer value multiplied with an integer value is an integer value. So we print num5, and in this case it will be 16. So let's run this code. And it printed 16 to our screens. And now we'll talk about division. And division is different. So let's test division. So we type num6 equals num5 divided by whole num. And here we will state that two integers or two integer values divided with each other returns a float if a single division sign or slash is used. So we print num6 and this will return 16 divided by 5 or 3.2. So let's run this code. And here we can see that we had 3.2 printed to our screens. And 3.2 is not an integer, but another data type, which we will talk about in the following video lectures, which is called a float. So now we'll perform some type checking. So we type checking and we print the type of num5 and we print the type of num6. And in the first case of these two lines, it will print that the object is an integer. And in the second case, it will print that the object is a float. So let's run this code. And here you can see that num5 is an integer and num6 is a float. So all right, the reason that integer division is different is because it is executed by different circuitry in the computer or central processing unit or graphical processing unit. We do, however, have the option of floor division. So let's test floor division. So we type floor division. And here we create num7 equals num5 floor divided by whole num. And here we state that two integer values floor divided with each other returns or creates a rounded integer. So we type print num7 and we type check it. So let's run this code. And here we can see that we returned 3.2, floor divided became 3. It is rounded. and it is an integer. So, all right, let's take a look at the use of integers as a part of native Python functions. So we type integers can be used to keep track of loops, or you could say Python loops. So we type for x in range of 1 and 6, print x. And this code will use an integer x, and for every iteration or execution of the loop, increase x with +1 from the integer 1 until x is less than the given integer 6, which is 5. So let's run this code. And here we can see 1, 2, 3, 4, 5. And this is one of the reasons that integers are important. They are used to keep track on all things, for example, loops, positions in arrays, numbers, and all such things. As a matter of fact, even when you see these characters on your screens, behind every one of these characters is an integer number that corresponds to, for example, the letter T or the letter W or all the other letters. So everywhere on your screen there is integers, and you simply can't escape having knowledge about integers when you type code. So all right, now we'll take a look at converting other Python data types to ints. So let's type other data types can be converted or cast as integers if the data type's value is suitable. So we type num8 equals integer 5.5. And this code will cast a float 5.5 as an integer with the value 5. And we can type number 9 equals integer, and in this case we give it a string 3, and this will cast the string 3 as an integer with the value 3. And we will print num8, and we will print the data type of num8. We will print 9, and we will print the type of 9. Num9. And let's run this code. And here we can see that we successfully converted our casted floats and strings to ints. So now we have learned how to cast or transform, for example, returns from other libraries to Python ints or other simple Python data types to the Python integer data type. All right, this has been a fast first practical hands-on video lecture about Python integers for data handling. In the next video, we will teach you even more. And if you continue and use the same notebook, please remember to delete the currently used cells or simply start a new notebook. We look forward to see you in the next video.